this is 1.5 day 2. We got to talk about completing the square, and completing the square will always work. It takes a little bit of time. So there's my 6-step process that obviously will have a little bit stuff in between there. This is just kind of the skeleton. Separate variables from all else. Make sure you have a equal 1. Still, we always like to have a equal 1. There are going to be times where a might not be 1, so therefore, the only way to guarantee that a is equal to 1 is if you divide everything by that a value. Once you get to that point, you will have the ability to complete the actual square. You take the new b term, if you had it divided by a, the new b that's in front of the x, you divide it by 2, square it, add it to both sides. You're going to see that when we get to do one of these problems that I am purposely going to leave it as a 1/2 b in parentheses squared on the side with the variables, and on the other side I will simplify it. Because to step 4 it makes it really easy to factor because it's always going to be this way. I'll show you in a second. And then we can simplify the other side and then solve it as normal by taking a square root to get rid of the square. Bring it over, don't forget your plus or minus, and we are happy. I got 2 examples on here. We just want to solve them by completing the square. Would it be okay if I just go to the second one that has 1 extra step to it? I say we do the part B. Okay, you guys are saying we'll do both. We'll do both. So starting off with the first one then. The first one, you're trying to kill me. I walked over it 3 times and I still tripped on it. I was just trying to go until I tripped. So, first step was, again, separate the variables from everything else. And so to do that, I will subtract 13. That allows me to get this. Now, Mr. Konchak, you just left the space. I've done these enough times to know that if a is equal to 1, I can move to step, I think it was 3. And step 3 said I can start to add something. I can recognize there's nothing in front of the x squared. That means a is 1. So I will automatically go and say I am going to add something to both sides. I put the spaces in. To me, it just kind of gives me that hint, that idea that you need to start doing something more. So we recognize a is 1, so I automatically say, I'm going to add something to both sides. And what is that something we're adding?
Half of b squared.
Half of b squared. B is, what's b?
8.
It's not 8, it's negative 8. And so half of negative 8 is negative 4 squared. On the left-hand side, which is the variable side, I am writing this as negative 4 squared. But we all know that negative 4 squared is 16. So on the other side, I will actually simplify it out. Does anybody remember why we do this? I know everyone in here has done this before. But the next step says factor. Well, guess what? What this does is it sets up a perfect square trinomial on the left side. And so, to factor it, all you do is bring down an x, and you bring down minus 4, and you square it. If you want, you could make that a 16, and then you could look for the factors of 16. That'll give you an 8, and then go and factor it, but you'll find out it's x minus 4 and x minus 4, which is x minus 4 squared. So we leave it as something squared, knowing that's the value that's going to go into the factor. Saves us about 5 seconds, 10 seconds, maybe longer. And then what's negative 13 plus 16? And from here, now it looks like exactly like the homework you guys did last night by taking the both sides. And don't forget the plus and minus. So x minus 4 equals plus or minus the square root of 3. This actually looks like one of the examples we did yesterday. I don't know if I'm correct on that one or not, but maybe close. No, that was a 5. And then I can add 4. I'm moving quick because we've done this before. Leave it there, guys. I don't want a decimal unless it asks for it. If it does, there are 2 answers. Everybody good? Obviously, that was not factorable. There are no factors of 13 that will give me a negative 8. There's only 1 in 13. So you had to factor it if you wanted to solve it. You guys should remember that there are 3 different choices for quadratics. And what I mean by that is, I'm just going to draw it here. If this is the x-axis, we are looking for where does the parabola, right, cross the x-axis. It can do it twice, it can do it once, or not at all. And when there's not at all up here, what kind of solutions are those? You guys remember? Starts with an I. Imaginary. So they're imaginary solutions. Guys, completing the square works. It gives us imaginary solutions as well. Okay, that's the cool thing about completing the square. It doesn't matter what type of solution it is, it will always work. Can we move on to the second one? There's options on this one, actually, I recognize. We're not going to take the appropriate action. We're going to go the long way here. On the second one, what's the best appropriate thing we should do on this problem? We should factor a 3 out, or divide both sides by 3. And if you do that, the 0 side, 0 divided by 3 is still 0. So it doesn't change the problem, right? What you do to one side, you do to the other. But let's just say we didn't recognize that. We're just in too much of a rush. We're going to complete the square using the other steps, using our steps first. We're going to find out it actually still will come out okay. So the first thing I should do then is subtract the 6. Notice I didn't really leave myself room now to add something to both sides because A was not 1. So now I got to make A 1. To make A 1, I divide both sides by 3. You could factor a 3 out and then divide it out. Yes? There's multiple ways to do this. If I wanted to factor a 3 out and leave it out front, it will mess with me when I go to add things to both sides. You kind of run across that when you're transforming a quadratic in standard form and you want to put it in vertex form because you have to complete the square to do that. And I think we get to that this year. So you should get x squared minus 4x plus something equals negative 2 plus something. Will this always end up giving you nice numbers when you divide by a? No. So sometimes you might have something like 5 halves in the middle for a b term. Just remember, sidebar here, if b happened to be 5 halves, what's half of 5 halves? It's not 10 halves. 5 over, well, couldn't I just multiply it by half? So there'd be 5 over 4. So basically take any fractions and multiply it by half instead of taking half. That might help you guys out. So we're going to take that away. So continue on our problem. What's b now? Negative 4. Half of negative 4 is negative 2, and then I square it, but negative 2 squared is, so not so bad. Now, the cool thing about it is, the factor becomes, what? X minus 2 squared equals 2. And then we just square square root. Don't forget plus or minus x minus 2 equals plus or minus the square root of 2. And then add 2. So x equals 2 plus or minus the square root of 2. And we are done. And the next one is if we had the time or the willpower, which I'm assuming most of you guys don't, we could start with the ax squared plus bx plus c equals 0. We could perform the completing the square on that with no numbers, and I would end up with something we call the quadratic formula. Some of you guys probably from like 8th grade probably have a little song for that. I hear it every year, but I do not know it personally. But negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm assuming you have that committed to memory already. Because this always works, because completing the square always works, and completing the square built this. So I have 3 examples. I really don't want to do all 3, but I think b looks to be the silliest, yes? Well, actually either one of them. So let's do b instead. Guys, I'm going to tell you this. If you're going to use a formula, you're going to write the formula. Because that's the best way for you to play coach and put things into the right place. I understand that you guys probably have this committed to memory, but if you guys are going to want to make sure you have it written down correct, to fill it in correctly, I would write it down first to make sure you have it right, and then you can start to fill in. So yeah, I want you to write negative b plus or minus the square root of, b squared minus 4ac all over 2a. And you may want to get into the habit of actually listing what a, b, and c are. I mean, I require this of my younger students. I'm not sure if you guys necessarily need to know how to do that yet or anymore, because it should be natural. You can look at it and say, oh, I know a is 4, b is 12, and c is 9, right? You guys should be able to look at a quadratic. There's a lot of students out there still that still put, oh, a is 4x squared. B must be 12x. No, remember a, b, and c are the coefficients. Now start playing coach. X equals the opposite of what? 12 plus or minus the square root of 12 squared minus 4 times 4 is a times c is 9. Sorry, that's a little bit smaller on your screen there. All over 2 times 4. The opposite of 12 is just negative 12, yeah? Plus or minus the square root 12 squared. And the question comes down to what would be easier. Well, it's a negative times a positive times positive, so we know we're going to be subtracting. And you could do 4 times 4 to get 16, and times that by 9. You could do 4 times 9 to get 36, and 36 times 4. That might be a better option because 36 times 2 is 72, and you just have to multiply 72 by 2. So we definitely know it should be 144. Hey, nice, all over 8. And 144 minus 144, so it's negative 12 plus or minus the square root of 0 all over 8. Well, the square root of 0 is 0. So there is no plus or minus. It's just negative 12 over positive 8. Or divide by 4, you get negative 3 over 2. Hey, there's only one answer. Wasn't there supposed to be 2? Why not? Because the square root of 0, there is no plus or minus anymore. And what is this what kind of graph would this represent? We kind of talked about that quickly on the last page. How many times does it cross the x-axis? once. So if I actually had the graph of this, you would just kind of see it doing that, right? Now that I saw that results, I'm assuming, guys, this one over here on A, there should be 2 answers. And then the third option for quadratics are no solutions. So I'm assuming C has no solutions because you'll have the square root of a negative number. So be careful on that. So the discriminant, it just helps us discriminate between how many solutions and their type there will be. So the discriminant of a quadratic in standard form is, right here, b squared minus 4ac. This stuff that's underneath the square root. If it's positive, if you take a square root of a positive number, you have 2 answers, plus or minus. The square root of 0 is only 0, so there's only 1 answer. And if it's less than 0, that means there's no real solutions, but there's 2 imaginary because you'll have I. So each one of these, 2 real, 1 solution, and no real solution. Notice, I think we just did this one in the last page, yes? Isn't that not the exact same problems almost?
No, it was all positive.
Oh, they're all positives on that one. Okay. But that's what's happening here. I've got one with 2 solutions, one with 1 solution, and one with no solutions. So, which one do you guys want to do? No solution. Now, notice the directions. And the directions in your book will be stated the same way. It'll just say, use the discriminant. It does not say, use the quadratic formula or actually solve to find them. And so, you need to just do b squared minus 4ac and tell me if it's positive, when you're done, there's 2 solutions. If it's 0, there's 1. And if it's negative, there's no real solution. We'll then also say that there are 2 imaginary solutions to that. Any questions on that? I'll give you 30 seconds to do that. Okay, let's start filling her in. What's b? Negative 2 squared minus 4 times 1/3 times 4. Notice, guys, that I am using parentheses every time I use substitution. It's that way I know that I have some negatives going on. I also can make sure I group things correctly. Negative 2 squared, though, is positive 4 minus 4 times 4 divided by 3. 16/3. Now you have a choice here. You have a choice as in you can get a common denominator, or you can convert that to a decimal, because all we're really kind of figuring out is this positive, is it 0, or is it negative? Let's just get a common denominator instead, because we should practice those skills. What I do to the bottom, I do to the top. What do I need to do? By 3. So this ends up being 12/3 minus 16/3, which is odd. So, if that is the discriminant, that's not the answer. The answer is what? No real solution. Because I was asking us to determine how many solutions, and so no real solutions. That's as far as the book wants you to go, because it's asking how many real solutions. But I, guys, would want you guys to take it one little step further and say 2 imaginary solutions as well. Okay? So yes, I want you to state there's no real, but I want you to also state, hey, there's 2 imaginary solutions in there. Just so that we can say, hey, we know a little bit more than what it's asking us. Homework on day 2 is page 57, 27, 28, 37, 38, 65, 70, and 77. Have a fantastic day.